So your quiz, like I said, is just on 1.3. If you remember from 1.3, you're telling whether or not something is a function, whether it's a table, a graph, an equation. Then you're also finding the domain of functions. So those are, remember, if x is not in the denominator or not under a radical, it's just all real numbers. And then if x is in the denominator, you're taking the expression with x in the denominator, setting it not equal to 0, then solving for what x can't equal. Then if x is underneath the radical for the square root, you're taking the expression under the radical and setting it greater than or equal to 0. Then you're also evaluating functions. So you're going to be given a function, told to find f of something. The first section in your review goes over determining whether each relation represents y as a function of x. So with number 1, you're given a table that has input values and output values. Remember, your input is your x, your output is your y. So with these, your x values cannot repeat. So if we look at those x values, you have -3, 6, -2, 1, and 3. None of those values repeat themselves, so this one is a function. For number 2, you have a line drawn on a coordinate plane. Yes, it's a squiggly line, but we said that when you're testing graphs, you use your vertical line theory. So if you draw a vertical line at anywhere and move that vertical line around on that coordinate plane, the only time that that vertical line will cross the line that's already drawn is one time if it's a function. It does not matter where you draw this line on this function or on this coordinate plane, you are going to only cross one time. So this one is a function as well. For example 3, you have one that has y squared is equal to 3x plus 4. Now, because you have this squared on the y, because it's raised to, y is raised to a power, this one is not a function. Remember, with our equations, we said that if it was a function, y is not raised to a power, it's not in the denominator of a fraction, and it's not in absolute value bars. So because this y is raised to a power, that's what designates it as not a function. For number 4, you have y is equal to -4x squared minus 3x plus 7. You don't have y raised to a power. Y is not in the denominator of a fraction, and y is not inside absolute value bars. So this equation represents a function. So the next part of your review, you're going to state the domain of the functions. So with number 5, you're given f of x is equal to 15x cubed plus 7x squared minus 9x plus 4. Do we have x in the denominator of the fraction? No. Do we have x inside a radical or inside a square root? No. So automatically, your domain for this one is all real numbers. So if you want, you can give it to me as -infinity to +infinity, or you can just write all real numbers. So the symbol for all real numbers, which is that double-backed R. I'll take either one of them. For number 6, we're given g of x is equal to 3x plus 2 over 4x minus 9. Do we have x in the denominator of a fraction here? Yes. So you're only going to take the part that's in the denominator, which is the 4x minus 9, and set that not equal to 0. You're going to use that to solve for x. So first thing we do with that is move your 9 over, so we'll add it to both sides. That gives us 4x is not equal to 9. Then we divide each side by the 4 to get that x cannot equal 9 over 4. For number 7, you have h of x is equal to the square root of 2x minus 8. For this one, you have an x underneath the square root. So you're going to take the entire expression under the square root and set it greater than or equal to 0. So you're going to have 2x minus 8 is greater than or equal to 0. From here, we're going to just solve for x. So we're going to move that 8 over first by adding it to both sides. This gives us 2x is greater than or equal to positive 8. From here, we divide each side by the 2, and we get that x is greater than or equal to 4. So this domain is just x is greater than or equal to 4. The next part of your review goes over evaluating functions. So for number 8, it tells us f of x is equal to negative 3x squared plus 7x minus 9. We're finding f of negative 4. So if we plug this negative 4 in anywhere we see an x and then simplify, that will give us what f of negative 4 is. So f of negative 4 is going to equal negative 3 times negative 4 squared plus 7 times negative 4 minus 9. Simplify that negative 4 squared first. That's going to give you negative 3 times 16 plus 7 times negative 4 minus 9. From here, multiply. So you're going to multiply the negative 3 times 16 and the 7 times negative 4. Your negative times a positive is going to give you a negative. 3 times 6 is 18. You carry the 1. 3 times 1 plus 1 is 4, so that's negative 48. The 7 times negative 4 is negative 28. And then you have that minus 9 as well. I'm going to do this with the negative 48 minus 28 first. They are the same sign, so you're going to keep the sign and add the numbers. Your 8 and 8 is 16. You carry the 1. 3 and 4 is 7, so it's negative 76 minus 9. Again, same signs, keep the sign, add the numbers. That gives you a negative 85. For number 9, you have f of x is equal to 7x cubed minus 3x. You're finding f of 2. So again, we're going to plug in that 2 anywhere we see an x and then simplify. So that's going to give us f of 2 is equal to 7 times 2 cubed minus 3 times 2. Simplify that 2 cubed first. 2 times 2 is 4, times 2 is 8. So that's 7 times 8 minus 3 times 2. From here, multiply. Your 7 times 8 is 56. The negative 3 times 2 is negative 6. So that's 50 minus 6, which gives us 50. For number 10, we have f of x is equal to 3x squared plus 2 over x minus 5. We're finding f of negative 1/3. So that means we are going to put that negative 1/3 in for x on both the top and the bottom of this fraction. So it's going to give us f of negative 1/3 is equal to 3 times negative 1/3 squared plus 2 all over negative 1/3 minus 5. Simplify the negative 1/3 squared first. So negative 1/3 times negative 1/3 is going to give you a positive 1/9. So that's 3 times 1/9 plus 2 over negative 1/3 minus 5. Multiply the 3 and the 1/9. 3 times 1/9 is 3 over 9, which simplifies to be 1/3 plus 2 over negative 1/3 minus 5. If you want, separate this using division, because fractions are division. It's going to be equal to the same thing as 1/3 plus 2 divided by negative 1/3 minus 5. That 2 is over 1, that 5 is over 1. You need like denominators in order for you to add or subtract these fractions. So with that 2 over 1, you're going to multiply it by 3, top and bottom. That's going to give you 1/3 plus 6 over 3. For the 5, or the negative 5, you're going to multiply top and bottom by 3. So that's going to give you negative 1 over 3 minus 15 over 3. From here, simplify inside those parentheses first before you do the division. The 1 plus 6 gives you 7 over 3 divided by negative 1 minus 15, or negative 1 plus negative 15. Same signs, keep the sign, add the numbers. That's negative 16 over 3. From here, you're going to keep, change, and flip. So that's going to give you 7 over 3 times 3 over negative 16. Your 3's are going to cross simplify to become 1's, and that just gives you negative 7 over 16. For number 11, you have f of x is equal to negative 2x plus 6. You're finding f of x minus 3. So for this one, we're going to plug in the x minus 3 in for x. So this x is going to change into x minus 3. So it's going to give us f of x minus 3 is equal to negative 2 times x minus 3 plus 6. First thing here to do is to distribute that negative 2 into the x minus 3. So it's going to give us negative 2x plus 6 plus 6. From here, you have like terms with those 6's. So that's going to give us negative 2x plus 12. For our next example, we have f of x is equal to 3x over x plus 2. We're finding f of x squared minus 3x. So this is going to simplify or be plugged in anywhere we see the x on the top and the bottom of that fraction. So we're going to have f of x squared minus 3x is equal to 3 times x squared minus 3x over x squared minus 3x plus 2. Up top, we're going to distribute that 3. That's going to give us 3x squared minus 9x all over x squared minus 3x plus 2. I don't want you to do anything else with this. I want you to leave it just like this. Your bottom, you can factor. However, you're not going to be able to simplify anything else from here. If you were to factor, this is what I want you to give me. If you were to factor this bottom, though, and the top, you'd be going backwards with the top, which is not what I want you to do. So that would give you 3x times x minus 3. And then the bottom, you have factors of positive 2 that add up to be negative 3 of negative 1 and negative 2. So that would just be x minus 1 times x minus 2. Simplified form, factored form would be what's in the purple. I don't want you to give that to me. I want you to give me what's in the blue that has a box around it. For 13, you have f of x is equal to negative x squared plus 6x minus 8. You're finding f of 3x plus 1. So for this one, f of 3x plus 1 is going to equal the opposite of 3x plus 1 squared plus 6 times 3x plus 1 minus 8. This 3x plus 1 squared, it's raised to the second power. So you have to separate it and FOIL it out. So this is going to be rewritten as the opposite of 3x plus 1 times 3x plus 1 plus 6 times 3x plus 1 minus 8. Again, I'm going to FOIL the 3x plus 1 times 3x plus 1 first. This is going to give me the opposite of 9x squared plus 3x plus 3x plus 1 plus 6 times 3x plus 1 minus 8. From here, combine like terms inside the parentheses. You have the 3x plus 3x, which is going to give you 6x. So this turns into the opposite of 9x squared plus 6x plus 1 plus 6 times 3x plus 1 minus 8. From here, distribute. You have a negative in front of the 9x squared plus 6x plus 1. You have a 6 in front of the 3x plus 1. So you're going to be distributing both of those. The negative times 9x squared is negative 9x squared. The negative times 6x is negative 6x. The negative times 1 is negative 1. The 6 times 3x is 18x. The 6 times 1 is 6. And then that minus 8 drops down. From here, you're going to combine like terms. That negative 9x squared does not match with another x squared, so drop it down. Next, you have negative 6x plus 18x, which is positive 12x. Lastly, you have minus 1 plus 6, which is 5. Minus 8 is negative 3. Again, I don't want you to factor this. I want you to leave it just like this. So this is going to be your answer that you give me. For our last question, you have f of x is equal to 5x squared minus 3x plus 11. You're finding f of 5x plus 2. So we're going to do f of 5x plus 2 is equal to 5 times 5x plus 2 squared minus 3 times 5x plus 2 plus 11. Again, you have a binomial squared, so I'm going to separate that and FOIL it. So it's going to turn into 5 times 5x plus 2 times 5x plus 2 minus 3 times 5x plus 2 plus 11. So again, I'm going to FOIL the 5x plus 2 times 5x plus 2. That's going to give us 5 times 25x plus 10x plus 10x plus 4 minus 3 times 5x plus 2 plus 11. From here, I'm combining like terms inside the first set of parentheses. So that simplifies to give us 5 times 25x squared. Sorry, this should be squared. Oops. There we go. Plus 20x plus 4 minus 3 times 5x plus 2 plus 11. So from here, I'm going to distribute. The 5 is going to go inside the trinomial. The negative 3 is going to go into the binomial. So 5 times 25. Your 5 times 5 is 25. You carry that 2. 5 times 2 is 10 plus 1 is 12. So that's 125x squared. Then the 5 times the 20x is going to give you 100x. Then the 5 times 4 is 20. The negative 3 times 5x is negative 15x. And then the negative 3 times 2 is negative 6. Drop the 11 down, and then from here, combine like terms. You don't have another x squared, so that 125x squared drops down. You have 100x minus 15x, which is going to give you a positive 85x. Next, you have the 20 minus 6, which is 14, plus 11, which is 25. So you have 125x squared plus 85x plus 25.